Hey A&Pers, this is Dr. Jones checking in. This is a bonus video for A&P2 Lecture Test 2 covering not the note set, but the endocrine review. And this is a separate document available to you on Canvas. It's a separate document because the words go the other direction in order to make the sentences fit on the page. So anyway, in lecture, when we have time, we often go through this together, so I thought we would give it a go. I've tried typing on this, it doesn't work. I tried writing on this, it doesn't work very well either, but I can point with our little stick and, you know, draw a little. It's the Galaxy pen. So fun. Okay, so there are two hormones involved in calcium homeostasis, and that's CT, which is calcitonin, and PTH, which is parathyroid hormone. Again, it was called parathormone back in the day, which I still think sounds cool, but it's parathyroid hormone now. So parathormone still sounds better. So when blood calcium levels are too high, so here's our sine wave. When blood calcium levels are too high, the thyroid gland secretes calcitonin, and that lowers blood calcium by excreting calcium at the kidneys, which means you pee out more calcium. And it prevents calcium absorption by the GI tract. When blood calcium levels are too low, the parathyroid glands release parathyroid hormone, parathormone. And that raises blood calcium levels by making osteoclasts and activating osteoclasts so that they do more and making new osteoclasts. And it also makes you retain calcium at the kidneys, which is science code for you pee out less calcium. Parathormone also raises blood calcium levels by making the kidneys make the hormone calcitriol. Calcitriol. That's an R. Excuse me. And that increases the dietary absorption of both calcium and phosphate groups. And it's the one with the vitamin, it's because of the cholecalciferol, the vitamin D3, which is made at the skin in the presence of sunlight, and the cholecalciferol gets turned into calcitriol, and that makes you absorb the calcium from your food. Okay, blood sugar. Hormones involved in the regulation of blood glucose are insulin and glucagon. When blood glucose levels are too high, it disappeared. Oh, it still disappeared. Okay, that one stayed. So when blood glucose levels are too high, the beta cells of the pancreatic islets secrete insulin. And it lowers blood sugar by increasing the glucose uptake into the cells and by making glycogen. I'll have a water in a second. I tried to record this before, and of course at the end it turned out it hadn't recorded anything. I never know until the end of the video if it's recorded or not. I don't know why. Of course the last time I didn't have a coughing fit on camera, so. Excuse me. Blood glucose concentrations are too high, the beta cells of the pancreatic islets release insulin. And that lowers blood sugar by making the blood sugar go into the cells. I think it just switched to night mode. Everything changed, but I think it's just the color of the background changed from light to dark. I think we're good. So basically, insulin stores and uses the sugars. When blood glucose concentrations are low, the alpha cells of the pancreatic islets make glucagon. When the glucose is gone, release glucagon. And it raises blood sugar by breaking down glycogen, releasing the glucose, which is releasing the stored sugars, which is called mobilizing energy reserves. There's a term for that. Blood volume, we have a whole slew, a veritable plethora of hormones and an enzyme. So when blood volume is too low, this happens. When blood volume is too high, this happens. Let's see if it'll erase that or not. Okay, so when blood volume is too low, the kidneys secrete the hormone EPO, which is erythropoietin, and it makes red blood cells. You know what, let's just draw a red blood cell. There you go. When blood volume is too low, the kidneys also secrete the enzyme renin, and remember this is one in renin, R-E-N-I-N. R-E-N-N-I-N, renin is something else entirely, and we'll get to that when we do digestive. This one's R-E-N-I-N, renin. And it starts the renin, angiotensin, aldosterone system. Make that a capital R. There you go. And renin converts angiotensinogen into angiotensin 1, and the lungs convert that to angiotensin 2. Angiotensin 2 stimulates thirst and causes the zona glomerulosa of the adrenal cortex to secrete aldosterone. And aldosterone retains water and sodium at the kidneys and excretes potassium from the kidneys, which again is code for you pee out less sodium and water and you pee out more potassium. So it increases blood volume, which is going to be true of all of these, are going to increase blood volume. When you increase blood volume, that increases blood pressure. Angiotensin 2 also causes ADH, antidiuretic hormone, to be released from the neurohypophysis, the posterior pituitary gland. And the ADH, of course, is formed by the hypothalamus and released at the postpit. And ADH causes the kidneys to retain water. So you'll pee less, but you'll pee out the same amount of solute, just with less water. And then the absolute opposite, when blood volume is too high, the heart secretes ANP and BNP, the natriuretic peptides, ANP and BNP, alpha and beta. And they lower blood volume by making you excrete more sodium and water at the kidneys. So you pee out more sodium and water, which will lower blood volume. And when you lower blood volume, that lowers blood pressure. It also inhibits renin, ADH, where did ADH go? And aldosterone. So it inhibits the three that I just circled. It suppresses thirst and it prevents other increases of blood pressure. Next page. Okay, the last time I tried to write on this chart, it just, like, everything dropped, which is really distracting. Like that. So the hypothalamic hormone, thyrotropin releasing hormone, causes the ant pit to release thyroid stimulating hormone, which of course is thyrotropin. Thyrotropin releasing hormone causes the release of thyrotropin. Thyrotropin releasing hormone. And so this thyrotropin, thyroid stimulating hormone, the target organ is of course the thyroid, and it causes the thyroid to make T3 and T4. I don't know why it does that. The targets are most cells. That's a cell. And the effects are calorogenic, makes more ATP, generates more heat. Causes the release of TRH, that'll be low T3 and T4. What inhibits TRH, that'll be high T3 and T4. Next, corticotropin releasing hormone is CRH. They're just disappearing. Okay, pituitary hormone here is ACTH. Really? Oh my good criminy. Okay, I'm not going to write them down. That's frustrating. The endocrine target organ is the adrenal cortex, and the secondary hormones are glucocorticoids and androgens. Targets, lots of targets for the glucocorticoids. The effects are run from glucose metabolism to anti-inflammatory with a lot of details in between, but those are the two main concepts. Glucocorticoids are regulate glucose metabolism, and they are anti-inflammatory. Androgens are important in puberty. In adult men, not so much, because the interstitial endocrine cells make so much more androgen, generally. But in adult women, increases muscle mass, red blood cell formation, and libido. High levels of glucocorticoids inhibit the secretion of, it just disappeared, CRH. Next page. Gonadotropin releasing hormone is big G, little n, big R, big H. Hey, that almost lined up. And the pituitary hormones here are follicle stimulating hormone and luteinizing hormone. Okay. Follicle stimulating hormone in the ovaries causes estrogen and inhibin. In the testes, that's an E, just inhibin. At the ovaries, that causes follicle development. So follicle stimulating hormone causes the development of a follicle. I'm shocked. And the follicles make eggs. Oocytes, but. And in the testes, they support the nurse cells, which make sperm. So follicle stimulating hormone makes gametes, eggs and sperm. The luteinizing hormone at the ovaries makes estrogens and progestins and the corpus luteum. So the luteinizing hormone makes the corpus luteum. And the function of the corpus luteum is to pump out the hormones to maintain any possible pregnancy. And the main hormone to maintain a pregnancy is this progesterone that the arrow was aimed at when I drew it. So, going with it. The testes, it makes testosterone and is important in sperm maturation. So the luteinizing hormone makes the three types of sex hormones: the estrogens, the progestins, and the androgens. Okay, next is growth hormone. which is somatotropin. And we have growth hormone inhibiting hormone, growth hormone releasing hormone, and those both have somatoterms. Our first target organ here is the liver, and it makes the somatomedins, and they cause tissue growth and protein synthesis. So the growth hormone causes the liver to make somatomedin, which causes growth. The epithelium and CT, growth hormone causes stem cell division, which is literal growing new cells. Literally, you're dividing cells to make new cells. Growth. At the adipose, it releases fatty acids and is glucose sparing. There we go. I can dot it as I say it. And at the liver, again, so here's our second liver. It breaks down glycogen to release glucose and is therefore diabetogenic. What else broke down glycogen to release glucose? Didn't we already have that conversation today? Not that page. Glycogen. Insulin makes glycogen, but glucagon breaks down glycogen and releases glucose. So that is your review. With any luck, it actually recorded this time. I like the galaxy thing. It's so cool. Look at that. It's like, if you like, it's like a scratch off. It's like a solid. But then your next layer is different. So you can make layers of galaxies on Okay, I'm off track. So this has been a bonus endocrine review video for lecture test 2. AMP2 lecture test 2, video 10, but not covering the note set, covering the endocrine review. And I got a little off topic and drew some very fun pictures. So thank you for your time. Thank you for tuning in. The education must go on. Dr. J out. And now I look for the control, command, escape. And this time there'll be a video. Fingers crossed. Have a good one.